Wait, sorry, just give me a minute to get set up here. All right, seems. So I don't have a microphone today, which means I can't record the lecture the normal way. So I have to do this through Teams. So let's hope this works. All right, so I guess a couple of lectures ago, we saw that there was this using variable substitution. You could do things like replace characters in a string or remove characters from a string, but it was kind of awkward to do. Although it works for simple cases. If you want to do more complicated cases, there's a command that will do string substitution, character substitution, character deletion, and character removal of duplicates called tr. So the tr command is the one that translates, squeezes, or deletes characters. Now tr is a bit funny because it reads its input from standard in. Normally you'd like, for a lot of string operations, you'd like to read the result from a variable. Unfortunately, that's not the way tr works. So tr is also slightly awkward if you want to use it for straight up string manipulation. So tr is, you can think of it as basically being character-based search and replace for strings. So the way you use it is the command is called tr. It has a bunch of options, and then it takes in two sequences. So sequence 1 and sequence 2 are sets. They're supposed to be sets of characters, right? So in other words, they're just strings. They're supposed to be sets. So you're not supposed to have duplicates in sequence 1, although you might have duplicates in sequence 2 and where it would make sense. So basically all that happens in the when you're doing what's called translation, the characters in sequence 1 just get mapped to the characters in sequence 2. So for example, if sequence 1 was ABC, and sequence 2 was big A, big B, big C, then every time TR sees an A, it just maps it to capital A. Every time it sees a B, it just maps it to capital C. B. And every time it sees a C, it just maps it to capital C. All right, so to use tr in this way, right, you pass in both sequence 1 and sequence 2. So here's tr. There's our first string. There's our second string, right? So any character t is going to get mapped to the character t, right? So tr takes its input from standard in. So you have to arrange to give it a string via standard input. So one way to do that is either to use printf or echo, right? So echo writes to standard out. Printf also prints to standard out. Then you can take the output and pipe it to tr. So here I'm using printf. Now the way printf works is it takes a formatting string. So here's %s, right? And then it takes some argument to format, right? So this is the string x, right? So this says printf. So printf here will try to interpret whatever that is, right? The value of the string x, and it's going to format it as though it were just a regular string, so %s, right? So there's other so that %s is called a conversion. There's other types of conversions that you can do. So you can take a string and interpret it as an int with %d, for example. If you don't want to use printf here, you can just use echo. So you could also echo $x and then pipe the output to tr. So we've got the string sparring with a purple porpoise. Right, we're going to print that with printf here. Take standard output, pipe it to tr. Right, and that will replace every p with a t. And we're going to store that in y. Right, notice we're storing it in y with a command substitution here. So when you print this, not surprisingly, you get starring with a turtle tortoise, right? Replace every p with a t. You can do something similar. So another example here is replace every period with a slash, right? So here I've got a Java package name. I'm going to convert that into a Java directory structure or Java directory path. Right? Again, I'm just going to use printf to print the string, pipe the output to tr. And away you go. Okay, so when you specify the sequences, sequence 1 and sequence 2, or the sets sequence 1 and sequence 2, you can specify them in 3 different ways. Right, so you can actually explicitly list out the sequence on your own. Right, so you could write out A, B, C, D, E, F, G all the way through Z. Right. If you want to, you can use a range, but this is not portable. Right, so A hyphen Z are the characters A through Z. It works in Bash. It doesn't work in all types of shells. And then you can use the POSIX character classes that we saw. I don't remember when we saw these. We saw these earlier, though. So square bracket colon upper, that's the set of all uppercase letters. Okay, so normally when you use TR, the 2 sets have the same length because you're doing character to character mapping. So one way to convert from uppercase to lowercase or lowercase to uppercase, right, is to define your sequence 1. Right, so this is going to be the set of lowercase letters. Right, sequence 2 will be the set of uppercase letters. Right, so A through little a through Z and capital A through capital Z. Right, so TR is going to translate every lowercase letter to its corresponding uppercase letter. So if I take the string CISC220, print it, pipe it to TR, then we're going to get all caps CISC220 in this case. Not surprising. All right, so if sequence 1 is shorter than sequence 2, then you just ignore all the excess characters in sequence 2. All right, so this is the same example as before, except now I'm going to tack on the digits 0 through 9 to the end of sequence 2. Right, so sequence 2 is now A through Z, 0 through 9. And now do the same thing, you're going to get the same result. Oh, sorry. Translate from 2. Sorry, I've got the wrong sequences here. Sequence 1 and sequence 2. There you go. So if sequence 2 is longer, just ignore the extra characters. Now the order matters, right? So if you flip this around, 0 through 9, right? Now the C is going to get mapped to the 2, right? And you're going to get something weird. 28I, 2220. Right? So order does matter here. All right. So if sequence 1 is longer than sequence 2, then you have a problem because you're asking TR to translate a character from the first sequence, and there's no corresponding character in the second sequence. So what GNU Bash does is it extends the last character of sequence 2 so that the 2 sequences have the same length. Right. So in this case here, right, my sequence 2 only has the X in it, right, whereas sequence 1 has 10 characters in it. Right. And so what GNU Bash will do, it's going to extend the X so that there's 10 copies of the X. Right. In other words, all the digits will get mapped to X in this case. Right. So you're going to get CISC XXX. Right. This only works in GNU, or it's only guaranteed to work in GNU Bash though. If you want to do this in another shell or in a different implementation of Bash, this may not work. Right. So the POSIX standard says that the result is undefined. So this isn't guaranteed to work. If you want to make sure that it works, then there's another syntax that you can use. So you can duplicate a single character using this funny syntax here. Right, so place the character inside the square brackets and then place a star after the character. And so that will extend sequence 2 so that it has the same length as sequence 1. So here, sequence 1, that's all the digits again. So that's all the digits. This time I'm using the POSIX character class. Sequence 2 is is the character class X followed by a star. So TR is going to extend that X so that there's 10 copies of that X. So that's the portable way to do it. But really, the correct thing to do is to make sure your sequences have the same length. And now weird stuff happens if sequence 1 contains duplicated characters. Duplicated characters don't matter in the second sequence, but in the first one, it matters. Right. So here I've got CISC220. Sequence 1 has the characters C, then I, then S, then C. Right. Sequence 2 is big C, big I, big S. So little c will, it looks like little c should map to big C, little I should map to big I, little s should map to big S, right? And then you might imagine that because sequence 2 is shorter than sequence 1, we get an extra S here, right? So GNU Bash will extend the last character so that they have the same length, right? So that on this computer, it's going to be big CI, big C, big I, big S, right? Probably. Right. All right. So if you run this, the question is what does it generate as its output? So when you run it, it looks like it actually generates big CISS220. Right. So in other words, the C ends up getting mapped to that extra S that's here. And the fact that this first C maps to that uppercase C doesn't matter. Right. So it appears that what happens here is it's the last match that matters. Right. So that the last match for the C is capital S. And so you end up replacing all C's with the capital S instead. Right. So the point of that is make sure there's no duplicated characters in your first sequence, right? It's supposed to be a set. All right, so that's using TR to translate, right? So to translate from one character set to another character set. You can use TR to delete characters as well. Right, so if you pass in -D as your option to TR, then TR will operate in deletion mode. So in other words, it's going to delete every character it finds in that sequence from the input. Sequence, oops, I called it sequence. There's a lot of typos in this notebook. That's sequence 1. If you're using TR in deletion mode, then you don't specify the second set. If you do, you may or may not get an error depending on the implementation of TR. So in this case here, we've got the date, 2022-10-21, with a hyphen separating the month and date. Here we're trying to delete the hyphen. Right? And so if you run that, you get 2022-1021. So delete a single. You can delete more than one character. Right? So I can delete all the hyphens and the twos just by specifying the 2 in sequence 1. Oh, sorry. Now we get the funny hyphen message. There we go. Right. So notice the strange error that you get here. Right. If you put in -2, then when we do the substitution here, right, you get -2. And so now TR tries to interpret that as an option. So, there we go. Right, which is why you get the invalid option -2. So if you want to delete the hyphen, make sure it's not the first character of the sequence. Sorry, make sure it doesn't look like it's an option. Like that. You also have to be careful here that it doesn't look like a range. So if you wanted to get rid of all the characters between, so if you type in 2 through 6, for example, to get rid of the 2, the 6, and the hyphen, that doesn't work either. Right? That's going to delete all the characters 2 through 6. Like that. Right, so it's a bit tricky to deal with the hyphen. If you want to get rid of the hyphen, make sure it's at the end. That. Or on its own, like that. Okay, now if you've got repeated characters, so this is the one place that it's TR is actually very useful, is because it can delete repeated characters. There's something that you can't do with the string with the variable substitution. So if you have a string that contains a bunch of leading space or a bunch of trailing space, you can't use the substitution to delete the trailing and leading spaces properly, right? And preserve all the spaces preserve spaces in between. So to get rid of repeated characters, you can squeeze them using -S. Right? So -S will squeeze repeated characters that appear in the set sequence 1. And it'll replace it with just one instance of that character. Right. So here I've got a bunch of spaces here. Right. I've got a bunch of spaces here, and I've got one space there. If I squeeze out all the spaces, it'll replace that run of multiple spaces with a single space. Right. And it'll replace that run of multiple spaces with a single space. and it will leave that one on its own. Right? So if we run that, you end up with deleting all of the duplicated or repeated spaces. And you can squeeze and delete at the same time if you want to. Deletion happens first if you're doing that. So just remember that if you're squeezing and delete at the same time, deletion happens first, then the squeezing happens after deletion. And the deletion, and you specify two sets in this case. So sequence 1 are the characters to delete, and then sequence 2 are the ones that you squeeze. All right, so that's how to use TR to do some simple string substitutions. Right, it's usually a little bit easier to use than the well, it's sometimes more useful than the plain old variable substitution. Okay, regular expressions. So in the last lecture, we were talking about if statements, and I showed you how to compare strings for equality. And I told you that there's also a way to compare strings for a pattern, to a pattern called a regular expression. And that would be its own lecture. And so that's the rest of this lecture today. So a regular expression it's a language that's used to describe patterns of strings. Right, so that should sort of concern you right away, right? So regular expressions form a language. So you're trying to use a language inside of Bash, right? So you're using a different language that's not Bash to specify patterns of strings. Right. Regular expressions are very powerful. They're very common. They're very commonly used. They're also commonly overused. So there's a quote here from someone who wrote a very useful website that talks all about regular expressions. Right. So some people, when confronted with the problem, think, I know, I'll use a regular expression. Now you have two problems. Right? So your second problem is debugging the regular expression. Okay, so the confusing part about regular expressions in any language, but in Bash in particular, is that a regular expression typically uses symbols to specify the pattern. Unfortunately, the symbols it uses, some of the symbols are the same as what Bash uses. So you have to always remember, am I writing a regular expression or am I doing something else, right? And then you have to interpret your string appropriately. Right? So regular expressions are different from Bash's built-in pattern matching. So that's the other problem, right? Bash has its own pattern matching language, right? And regular expressions are different from that, right? Confusingly, they use the same symbols for specifying different types of patterns. So the idea of regular expressions comes from theoretical computer science. Right? So if you ever do any formal language theory, this is where the regular expressions came from. Typically, they're used for searching for text. You want to search text for some pattern or patterns. Now, regular expressions are very complicated, so there's no way you can cover this in any reasonable number of lectures, right? You can't cover everything that you would want to know about regular expressions. There's entire books that you can buy about how to write regular expressions. So we're not going to cover everything. We're just going to look at the important detail. Okay, so step 1, I want to match a regular expression. I want a string. I want to match a string to some to see if it matches some regular expression. So the syntax that you use in Bash, you use the double square brackets. Right? You take the string that you have. Right? That's on the left-hand side. On the right-hand side, you have your regular expression. So that's stored in the variable RE. Right? And you use equals tilde. So that operator there to test if string matches the following regular expression. So it's equals tilde. You have to be careful. There's an orange box down or a yellow box down here. You have to be careful about quoting that regular expression there. So if you quote the variable expansion that defines the regular expression, then that causes Bash to match the string instead of doing regular expression matching. Right. So in other words, if you quote RE here, then all you're getting is the string equal to the string RE. If you take part of that regular expression and quote it, then that quoted part of the regular expression is matched as though it were a string and not a regular expression, right? So you can actually you can actually have part of the regular expression be treated as a regular expression, and then the rest of it be treated as though it were just a string. Right? So be very careful when you're using quotes inside your regular expression. Okay, so this is a little script here is handy for debugging your regular expressions. Right, so all this script does is it takes in two command line arguments. The first command line argument is a string. The second command line argument is a regular expression, and it tells you yes or no, does the string match the regular expression? Okay, so how do you write a regular expression? So if your regular expression, your string, so your regular expression string has no special characters in it, right? So it's just a letter or a sequence of letters. Then those characters are matched literally. Right? Now the way this works is a bit odd. Okay, so if my regular expression is just the character A, right, then what that means is does the string contain at least one A? Right, so that's how it works for regular. That's how the pattern is defined. Right, so your pattern here is your A, and the question is does the string contain that A? Contain an A? So, for example, does the string hello contain an A? The answer is no. Right, so the string hello is not matched by the regex A. Right, so in other words, the if statement will be false in this case. Right. Does walrus contain an A? The answer is yes. So walrus does in fact match the regular expression A. Now that's a bit weird for most people when they see it the first time. Right, so most people when they see a regular expression A, they think that the string has to begin with an A, but that's not the case. Right, when you write it this way, it does the string contain an A. So if we change the first one, so does hello contain an E? It's going to say yes. Right. Does it contain EL? I'm going to say yes. Right. Does it contain EL? O? Right. So the answer here is going to be no. Right. There does not contain the sequence ELO. It contains the sequence ELL, but not ELO. Oh, so here's that example here, right? So if you have if your regular expression just contains a bunch of characters in it, then that's treated as a whole string. The first string has to contain the second substring, right? So that's going to be false, right? But Sandman does contain the and, right? So that will occur. Okay, so if you just have plain old characters, it's not too difficult to figure out what a regular expression does. Right? Basically, it's looking, does the first string contain the second as a substring? Right? But it gets a lot more complicated very quickly. So this table here is showing you what are called the meta characters that you can use in a regular expression. So a meta character in a regular expression is just a character that has extra meaning. The caret is called an anchor. So it matches the beginning of the line when used as the first character of your regular expression. Right. So if the caret is the first character of the regular expression, then that's saying, does your string start with the next part of the regular expression? Right. There's a corresponding anchor for the end of the string, so the $sign. Right. So the $sign is also an anchor. If it's at the end of your regular expression, then it matches the end of the line when used as the last character of the regular expression. Right. So in other words, does your string end with whatever's in front of the $sign? Let me just quickly see what examples we have here. Okay, so let's use the caret and the $sign as anchors. So I'm just going to go to my shell now. Here. All right, so my program's test regex. Okay, so I have the string hello. I want to know, does hello, so does it contain an H? So the answer is yes. Right. Does it start with an H? You would write caret H. Right. So yes, the string hello does in fact start with the H. Does it end with an O? So O dollar, right, is how you would test. Does it end with an O? The answer is yes. If you wanted to know, is the string hello actually the string hello, right? Then you would have to use the start and an anchor at the same time, right? So in other words, does the string start with an H, then have an ELL, and then end with an O? Right, and the answer is yes. All right, so those are your anchors. If you want to match any single character, that's the dot. Right, now remember back in when you're using wildcard matching, so for file name expansion, it's the question mark, right? Question mark matches any single character, right? And the dot is, I guess the dot is the current directory name, right? Inside a regular expression, the dot matches any single character. Right. So, does the string hello start with some character? Right, so the answer is yes, right? Boom. Right, does this, oops, sorry, H-E, right? Does the string hello start with some character, followed by ELL, ends with an O? Right, the answer is yes. I guess we can do this. So, oh, sorry, H-E-L-O. So replace the middle character with something, right? And now I can go in and change that middle character to whatever I want. All right, so the square brackets is what's called a bracket expression. It's also this, so it's similar to the other bracket expressions we've seen. It defines a set of character class, right? So inside the brackets, you can put any sequence of characters that will match any one of those characters. We have an example here. So here is an example here. So the regular expression, sorry, starts with, starts with an S, right there, ends with T, right? And the middle character is one of A, E, or I, right? So that will match sat, set, and sit, but it won't match anything else. You can use a range. So that will match S followed by any lowercase letter, followed by T. Now, when you use a range, if you want to include the hyphen as part of your character class, then the hyphen has to appear either as the first or last character in the character class. Okay. So here it appears as the first character. So this will also match S hyphen T. Right. So when you're matching the hyphen, it's always the first or last character of your character class. 0 through 9, that's just the numbers 0 through 9. Right, so that'll match file 0 through file 9. And then A dot C. Oh, this is interesting. So the dot inside of a character class matches the dot. It doesn't match any character, right? So if you actually want to specifically match the dot, then the way to do it is to put the dot itself inside of a character class. Okay, any questions so far? All right, so there's more. You can negate the character class. Right. So if you put the caret in as the first character of the character class, that says match any character that's not in the following sequence of characters. Is there an example here? There is not an example here. So let's try making one up. So not in the sequence. So let's do this one here. So file 0 through 9. So it's going to be file. Oh, sorry. Let's just do file. And so 0 through 9. Dot tf. Let's just do it that way. Okay, so this should match anything that looks like this, for example. Right. So if you put the caret in, then that will match anything. It won't match file 0, right? Because the caret means match any character that's not 0 through 9. Right? So it will in fact match file Z. Right? So that works. Right? Or file. You want to put in a wildcard character, you have to quote the thing. Right? So file question mark also works. Right? So anything that's not a 0 through 9. Oh, wait, what else do we have here? Caret, sub-expressions. Okay, so we're going to want the quantifiers next, right? Single character sub-expression or bracket expression is called enough. Okay, so a single character, so like the letter A, a sub-expression, so anything inside or round brackets. A bracket expression is inside round brackets, right? Yes, so a sub-expression's inside round brackets. And what's the other one? Or a bracket expression. These things. So any single character, a bracket expression like that, or a sub-expression, those are called atoms. So those are just the individual pieces of your regular expression. So if you want to know, do you have 1 or more, or 0 or more, or 0 or 1, you can use a quantifier. Right. So here's where it gets very confusing. Right. So now the star appears as part of your regular expression. Right. Similarly to the question mark. Right. You have to remember that the star and question mark here means something different than they mean when you're doing wildcard matching. Right. So star means match the preceding atom 0 or more times. Question mark is match the preceding atom 1 or more times. 0 or 1 time. And then plus is match the preceding atom 1 or more times. Right? So plus means the thing has to be there at least once. Right? Star means the thing might be there, and it could happen more than once. Right? Question mark means it's either there once or not at all. Oh, and then you've got the braces. So that lets you match the preceding atom at least m times and not more than n times. Okay, so let's take a look here. So these are the star, the plus, the question mark, and the braces are called quantifiers, right? They specify how many times the preceding atom has to appear. So dot, right? Any character, right? Star. So the star. Oops, sorry. The star. Whoop, last. It's hard to highlight stuff. The star modifies the preceding atom. Right? So the star modifies the dot. Right? Star means 0 or more. So this will match any string, including the empty string. So dot plus, right? Remember, plus means 1 or more times, right? Dot means any character. So that will match any non-empty string. I guess we should try those. So that's regex. So that's the empty string. And this is dot star. Like that. Right. So that is matched by the empty string. Right. If you change the star to a plus, right? Plus means 1 or more. So it's not matched. Right. So the empty string is not matched by the second one. Right. Question mark means 0 or 1. Right. So the question mark will match. So that means either the empty string or the string equal to that has 1 character. Right. So that also matches. Okay, so that thing there will match any string containing at least 1 digit, right? So that does not have an anchor on it, right? So there's no caret or $sign on that. So that's any string having at least 1 digit. If you slap the plus sign after it, it means the same thing, right? Because the plus is a quantifier, right? It means 1 or more. So it's the same thing. Okay, so if you write caret, right, then square bracket 0 through 9, and then plus, and then $sign. that matches any sequence of digits, right? Any sequence of one or more digits, right? So that gives you, that's equivalent to any unsigned integer. If you put the minus sign in front, right, on its own, that's just a regular character, right? So that will match any negative number now. So that's any negative integer. Okay, so if I want to match any signed or unsigned integer, I can do the following. Right, so inside square brackets, minus plus, and then a question mark. So the minus plus inside the square brackets means match either the minus or the plus sign. Right. Question mark means 0 or 1 of those. Right. So either no question, either no hyphen, no plus sign, 1 hyphen, or 1 plus sign. Right. So that will match any unsigned or signed integer value. Right. And of course, you can replace the 0 or 9, with a POSIX character class like that. Right. So you replace the 0 or 9 with square bracket colon digit colon square bracket. So that's star, plus, and question mark as your quantifiers. Right now, if you need more control over how many things are matched, that's when you use the braces. Right. So brace 1 means match exactly 1. Right. So that will only match the string XA. 1 comma means match at least 1. So that will match XA, sorry, XA, X followed by 1 or more A. Oh, yeah, right, sorry. You have to remember that these modifiers only match the preceding atom. So it only matches the preceding character in this case. So that will match XA followed by, or XAA, or XAAA, or so on and so on and so on. That one there will match 1A, 2As, or 3As after the X. That's it. Right. Okay. If you put a part of a regular expression inside of round brackets, then that's called a sub-expression, right? So it's just part of the expression that you're grouping, right? That gets treated as a single atom by bash. So when you put a modifier after that, right, that modifier modifies everything that's inside the ABC, everything that's inside the parentheses, right? So plus sign means 1 or more. So that'll match ABC, 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 or ABC, 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 and so on. If you've got multiple regular expressions, you can join them using the vertical bar. Right? So the resulting regular expression matches any string that matches either of the two joined expressions, right? So you can think of this as being OR. So if your regex is A or B, A bar B, right? Then the regular expression before the bar is the A, right? The regular expression after the bar is the B. And so that regular expression will match any string containing an A or a B. These are a bit tricky, so you have to pay a bit of attention here. Right? So what's the regular expression in front of the bar? It's the caret B. Right? What is it after the bar? It's cat dollar. Right? So that will match any string starting with a B or ending with cat. Right? So what's the part of the expression in front of the bar? It's caret B, so that starts with a B. Right? Or right, the string cat in this case. Right. So starts with a C, and then ends with A. Starts with a C followed by an A, ends with a T. So yes, okay. Now in the following one, the regular expression in front of the bar is caret B. After the bar is caret C. Right. So that will match anything that starts with a B followed by a T, or followed by an A ending with T, or anything that starts with a C followed by an A ending with T. All right. So if you want to match dates, you can look at the following regular expressions, right, and try to take them apart. So let's look at the first one. Right, so we've got a sub-expression here. Right, that sub-expression matches 19 or 20. Right. So it starts with a 19 or a 20. Followed by 2 digits. Right. So that will match any year between 1900 and the year 2099. Okay, this one has everything inside of round brackets. And there's a bar here. So regular expression in front, right, is 0, followed by 1 through 9. Right. Afterwards, it's 1, followed by 0 or 2. Right. So that's 0, 1, 0, 2, 0, 3, up to 0, 9. Right. That's the stuff in front. Or the stuff in back is 1, 0, 1, 1, 1, 2. So those are all the months written down using 2 digits. Right. So 0, 1 through 1, 2. And the last part here. Right. So again, everything's inside round brackets. Right. And there are 2 bars in this case. Right. So the first one is 0, 1 through 0, 9. Right. Or 1, 0 through 2, 9. Right. Or 3, 0 and 3, 1. So those are your days, 0, 1 through 31. Right. Put all 3 of those together and you can match a year followed by a month followed by a date. All right. Any questions so far on the regular expressions? They are not easy to write or debug. They're actually quite hard to do. Okay, so instead of just doing string matching, where you have a string and you match it to a regular expression, often you'll have a file or many strings, and you want to know, is there some pattern that occurs in this file and where does it occur? Right, so for example, if you tried to process a Java program, you might want to know things like how many for loops there are in a program, or is there a package declaration, or how many classes there are in this file, or something like that. Right, so you can use, so what you can use is you can use this program called grep to search a file for a regular expression. Okay. So grep is global regular expression print. So it searches a file for a regular expression, prints the location or the line that contains the matched regular expression. Right. Okay, so the regular expressions I've been telling you, they are written in a flavor called POSIX extended regular expression. There's many different types of regular expression languages. Right, so the one that we're using here is the POSIX extended one, right there. So if you want to use grep to match these types of patterns, you're supposed to pass in minus big E. Right. Now, normally, for many cases, you don't have to pass in the minus E, and the regular expression will work anyway. But if you want to make sure that it matches what I've been telling you so far, you have to pass in minus E. Right. So it's grep minus E, your regular expression, and then your file or files that you want to search. Oops, sorry. And if no files are given, grep will read from standard input. Okay, so I want to use grep to find all occurrences of the string zip. Right. I'm going to get my input from the ls program. I'm going to list the contents of user bin, and then I'm going to filter that through grep to find all of the files that contain zip. So let me just run that on its own inside of this shell. So ls root user bin, and then pipe that through grep and look for zip. Right. So that will find any program that contains the string zip, and you can see there's a surprising number of them here. Right. If you want to find just the ones that start with zip, right, then you just put in an anchor. So caret zip, all files that start with zip. There you go. Right. If you want to find all the ones that end with zip, put in the $, as your anchor at the end. Oh, sorry, $sign as your anchor at the end. Right, and that'll find all the programs that end with zip. Okay, here's an example using grep to print all lines of a Java source code file that start with a for loop. Right, so I want to find all Java lines that start with a for that contain a for start that start. Oh, print all lines of a Java source code file that start a for loop. Right, so where the keyword for appears. Right. The -n option in grep prints the line number, which is often useful when you're searching source code files. So if I run that there, it tells you all the lines, right, where the keyword for appears. Right, now notice this isn't perfect, right? It finds any comment that also contains the string for. Right, so it does find all the for loops, but it also finds extra stuff. Right, so you can get a little more sophisticated in your search. Right, so I can search for the string for. Right, now a for loop in Java is always for followed by a round bracket. You're allowed to have spaces in front of the round bracket. So I can look for 4 followed by 0 or more spaces, followed by the opening round bracket. The round bracket's a meta character, so you have to escape it or put it inside of square brackets. So I'm going to search for 4. I'm going to search for, oops, sorry. Oh, this is really hard to highlight in here, sorry. Okay, so to search for spaces, I'm going to search for any blank characters. So that's a space, a tab, or a new line. Right, so that's colon, that's square bracket colon blank. Right, star means 0 or more. Right, so that's 4 followed by 0 or more white space. Right, followed by the round bracket, but the round bracket is special, so it goes inside of square brackets. When you run that, now we lose the line that contains the comment. All right, last example, and then we'll call it quits because we're at just about at 20 after. Right. So if you want to search a web page or the source code for a web page for all of the anchor links, right, then you can look for the tag less than a. That will give you all of your tags or anchor. Those give you all your tags that start with the letter A. Right, and so that will find you all of your anchors. It'll also find you a bunch of other stuff too. So any other tag that starts with A, it'll also find. Oh wait, there's a space there, so no, it won't. Sorry, I didn't see the space. So that will in fact find all of your anchor tags inside an HTML document. I guess we'll call it quits there. So just a quick reminder, you do have a quiz on Wednesday, right? It is in here. There is an announcement on OnQ that explains what's on the quiz, and there are sample quizzes. There's a sample quiz from last week. Sorry? Yeah, it's the ones who got an email from me. Yeah, you read it.
I kept running into it somewhere I had to use that.
I have to stop. Oh, stop. Yeah.
Yeah.
I hope that recorded. I'm not sure that recorded. All right. Sorry.
So I have like when I was running my scripts,
Yep.
I ran them at the beginning using // and then the script name.
Yep.
But that would always give me an error on my substitutions. And then I went looking around, like all the substitutions I used, where it'd be like $, open bracket.
When you ran your script, yeah, you have to show me. That doesn't make sense. That should work.
But then I used dash space script name.
Yeah.